From the smallest possible length to the largest scale imaginable, the universe is ruled by limits. Speed, temperature, energy, time itself. These boundaries don't just define reality, they are reality. So, what are the absolute limits of existence? And what happens when you try to break them? Absolute zero. This is the ultimate freezing point of existence, sitting exactly at minus 273.15 degrees Celsius. Heat is just the vibration of atoms. The faster they move, the hotter an object is. As they slow down, the temperature drops. Absolute zero is the theoretical point where all atomic and molecular motion comes to a complete, dead stop. However, reaching true absolute zero is physically impossible due to the laws of quantum mechanics. The Heisenberg uncertainty principle dictates that you cannot know both the exact position and exact momentum of a particle. If a particle stopped completely, you would know both perfectly, breaking the fundamental laws of physics. Because of this, atoms will always retain a tiny jitter called zero-point energy, making absolute zero a hard, unreachable floor of reality. The speed of light. Clocking in at exactly 299,792,458 meters per second, this is the absolute speed limit of the universe. Calling it the speed of light is actually a misconception. It is the speed of causality. It is the maximum rate at which any information, energy, or massless particle can travel through the vacuum of space. As an object with mass accelerates toward this limit, the energy required to push it increases. By the time it approaches the speed of light, its mass becomes infinite, requiring an infinite amount of energy to accelerate it further, which is impossible. This speed limit is woven directly into the fabric of spacetime. If you were to somehow exceed it, you would break the law of cause and effect, meaning an event's result could happen before its cause. The Planck Length. This is the smallest measurable distance in the universe, sitting at roughly 1.6 times 10 to the power of minus 35 meters. It is so infinitesimally small that if a single atom were scaled up to the size of the entire visible universe, the Planck length would only be the size of an average tree. It is calculated using three fundamental constants: the speed of light, Planck's constant, and the gravitational constant. Below this scale, the traditional laws of physics completely break down. The concepts of gravity, space, and distance stop making physical sense, dissolving into a chaotic foam of quantum probability. It is the pixel size of reality. Trying to measure anything smaller than the Planck length is mathematically meaningless. The Planck temperature. Also known as absolute hot, this is the highest possible temperature matter can reach, capping out at 1.42 times 10 to the 32nd power Kelvin. This temperature was only ever achieved once in history, exactly one Planck time after the Big Bang. At this heat, the wavelength of the thermal radiation emitted by an object becomes exactly equal to the Planck length. If you somehow pumped more energy into the system to make it hotter, the physics would collapse. The energy would become so dense that it would instantly create a microscopic black hole called a Kugelblitz, trapping the heat inside. You cannot get hotter than the Planck temperature without literally tearing a hole in the fabric of space-time. The Chandrasekhar Limit. This is the maximum mass a white dwarf star can achieve before it catastrophically collapses. A white dwarf is the dead core of a sun-like star, held up entirely by electron degeneracy pressure, the quantum rule that electrons refuse to be squeezed into the exact same space. But this pressure has a breaking point. Calculated by astrophysicist Subramanian Chandrasekhar, the limit is exactly 1.44 times the mass of our Sun. If a white dwarf pulls in too much matter from a companion star and crosses this exact threshold, gravity overpowers the electrons. The star collapses inward in a fraction of a second and violently detonates in a Type 1a supernova, one of the brightest explosions in the cosmos. The Tolman-Oppenheimer Volkoff limit. If a dead star survives crossing the Chandrasekhar limit, it crushes its electrons and protons together to become an ultra-dense neutron star. But neutron stars have an absolute limit too. The TOV limit is the maximum mass a neutron star can hold before its own gravity overcomes neutron degeneracy pressure. This threshold sits somewhere between 2.16 and 2.27 solar masses. If a neutron star absorbs enough material or collides with another neutron star and crosses this exact boundary, there is no force left in the universe strong enough to hold it up. The star instantly collapses inward, crushing itself out of the visible universe and leaving behind a black hole. The Bekenstein Bound. This is the absolute maximum amount of information that can be stored within a specific physical volume of space. Discovered by theoretical physicist Jacob Bekenstein, this limit proves that the universe does not have infinite storage capacity. If you take a physical region of space and pack it with as much data as physically possible, at the quantum level, you eventually hit a mathematical wall. If you try to force just one more bit of information into that space, the sheer energy and mass density required to store that data will cause the region to collapse into a black hole. It implies that at its core, the universe operates like a massive, finite computer. The Hubble Horizon. This is the absolute edge of the observable universe. Because the universe has been expanding since the Big Bang and the speed of light is finite, there is a hard spherical boundary around Earth spanning exactly 46.5 billion light-years in every direction. Beyond this boundary lies the unobservable universe. Because dark energy is causing the expansion of space to accelerate, the space between us and galaxies beyond the Hubble horizon is stretching faster than the speed of light. The light from those distant galaxies will never, ever reach us, no matter how much time passes. They have crossed the absolute limit of visibility and are permanently erased from our reality.